Hi, this is Tom. Welcome to my channel. I'm going to share with you the drinker paradox. The drinker paradox is a paradox that was formed by logician Raymond Smullyan in a book I think it was written in the 70s. And this is the statement. In any non-empty bar, there exists a person such that if that person is drinking, then everyone in the bar is drinking. And this is a statement which on its face seems absurd. And the reason for that is that there's a difference between how we understand things in natural language and how language is interpreted in formal logic. So if I hear the question, somebody asks me, is it true that if I'm drinking, everyone is drinking? I would look at the other people and see if they're all drinking. And if they're all drinking, I would say, yes, it's true that if I'm drinking, everyone is drinking. But in formal logic, if I'm not drinking, then the answer to that question is yes. And that doesn't make sense intuitively. But according to the laws of logic, that's the way that it works. And this app will explain that. So this app was available at this URL, and I will post it in the description of the video. And I'm going to go through a little bit of the app. You can see there's 7 tabs to go through. If you're interested, it will explain everything in detail. And I'm going to look at just maybe 3 of the tabs here. So here's one of the tabs. So this tab here will go through the formal logic that's involved. So the first thing that we'll consider is if P, then Q. So this is what the paradox is using, with P being defined as someone is drinking or you are drinking, and Q is everyone is drinking. So if I'm a person in the bar and I'm asked the question, is it true that if you are drinking, then everyone is drinking? Then I should answer, like according to the laws of formal logic, I should answer true if either I'm not drinking, that's these 2 rows here, or I'm drinking and everyone is drinking. And a way that we can understand how this if P then Q works, this is the way that I found that made the most sense, is think of an argument that's sound in the way that we just normally think of arguments. So we think of an argument as sound if we say we assume something, and then there's a conclusion, and then we reason from the premise to the conclusion. And if the premise is true and the conclusion is false, then we think, well, that argument is sound. And if the premise is true and the conclusion, did I say that wrong? If the premise is true and the conclusion is true, we think that that is a sound argument. If the premise is true and the conclusion is false, then we think that that's an unsound argument. So let's think about an unsound argument. And we'll ask the question, is a given argument unsound? So if the premise is true and the conclusion is true, then it's true that the argument is not unsound. Now, if the premise is true and the conclusion is false, then the argument is unsound. So it's false that the argument is sound. Now, here's the tricky part. What about if the premise is false? Well, if we ask the question, is the argument unsound? Well, an argument is only unsound if the premise is true and the conclusion is false. So if the premise is false, then the argument's not unsound. And that takes care of the last 2 rows. So that's how if P then Q works. It's got one bad case, and that's the second row. if the premise is true and the conclusion is false. And that corresponds to if I am drinking and not everyone is drinking. That's the one bad case. Now, this is equivalent to where I've got highlighted there. So this funny looking symbol here is not. So this is saying it's not the case that the premise is true and the conclusion is false. And once again, there's one bad row. So if it's not the case that the premise is true and the conclusion is false, then every other row except for this row is okay. And then we have a third equivalency, which I think is the easiest to understand. And this is, and you can, if you think about it a bit, it's not hard, just takes a little time. But if you think about, if it's not the case that if the premise is true and the conclusion is false, then either the premise is false or the conclusion is true. And we can see that by looking at the truth table. Because here we have the premise is true and the conclusion is false. That's the bad row. So if the premise is false, then we're okay. We avoid the bad row. Or if the conclusion is true, we avoid the bad row. So if either the premise is false or the conclusion is true, then we avoid the bad case. Okay, I'm going to look at two more tabs, and these tabs will illustrate the idea. So we're going to look at the last case, that either the premise is false or the conclusion is true. And in terms of the paradox, so P is I am drinking, okay, and Q is everybody is drinking. So what we have is either I'm not drinking or everyone is drinking. So here we got four people. And the way the paradox works is it's asserting that there's somebody who has to answer this question, yes. So here's the question. Somebody has to answer the question, yes. So let's consider the first person. So if the first person is not drinking, then they answer the question, yes. Because is it the case that either you are not drinking or something else? Well, I'm not drinking, so yes, I'm not drinking. I answer the question, yes, if I'm not drinking. So I can only answer the question no if I am drinking. And then the second part of the question is, or everyone else is drinking. So if not everyone else is drinking, then I answer that question no. But if everyone else is drinking, I answer the question yes. So I look down the bar and look to see if there's somebody who's not drinking. And here's a person not drinking. So I say no, because I am not drinking and it's not the case that everybody is drinking. So I say no. And that's the only way I can say no. It has to be such that, like, I am drinking and there's someone else who's not drinking. And then we get to Bernard. Bernard is the same way. He looks at his mug is full. If you see somebody else, that person's mug is empty. The answer is no. Same thing for Clara, same thing to Dimitri. Then when we get to Elena, then that's where it ends. Elena has to answer the question yes. Because if her mug is full, everybody is drinking. The answer to the question is yes. And if Elena's mug is empty, which it has to be, because it can't be that everybody's drinking, because Alice already said that not everybody's drinking. So Elena's mug has to be empty. Elena has to answer the question yes. It is a case that either I'm drinking or everybody's. Yes, it's either the case that I'm not drinking or everybody's drinking. Or to put it another way, either my mug is empty or everybody's mug is full. That's what the question is. So somebody has to answer that question, yes. That's what this tab is showing. And there's an equivalent formulation that came to me. So I was trying to reason all this, which I thought was very elegant. I really liked it a lot. And that's in tab 3 here. And this is equivalent to the paradox that we set. So it's, here's the setup. There's a house rule that if everybody is drinking, then drinks are in the house. And then the claim is there's someone who will not have to pay. So if everybody's drinking, then nobody pays. Or if you don't have a drink, you don't have to pay. So we'll go through one by one. And first person looks at their mug. And notice this is exactly the same. There's several cases that are, the bad case is true and then false. True is, I'm drinking. False is, not everyone is drinking. So this is the same situation. Alice looks at her mug. Mug is full. Alice says, no, it's not the case that I'm drinking. And Alice says, no, it's not the case that everybody's drinking. Or the way that we formulated it here, the question is Alice free? There's someone who's not paying? Is Alice the one who's not paying? No, Alice has to pay. Why? Because Alice has a drink, but not every drinks are not on the house. Same thing with Bernard. Bernard has a drink, drinks aren't on the house. Clara has a drink, drinks are not on the house. Dimitri has a drink, drinks are not on the house. And then we get to Elena. Now, if Elena had a drink, she wouldn't have to pay because drinks are in the house. And Elena doesn't have a drink, and she doesn't have to pay because she doesn't have a drink. And again, it has to be the case that she doesn't have a drink because all of the previous people saw that drinks weren't on the house. So the answer to the question, no. So I made this as clear as I could. It is a bit confusing, but if you go through it, then it kind of hopefully clears up. But there is a lot of cognitive dissonance and pain and suffering involved, which I went through for your pleasure and enjoyment, so you don't have to. So I hope you enjoyed this, and thanks for watching. And one last time, I'm going to put the URL in the description of the video. And I hope you enjoy the app. Thanks again. Until next time.